Hello and welcome to INE's CCI Service Provider version 5 lab course. Today we will look at BGP attributes. For some of you who do not know me, my name is Rohit Pardasani and I would be your instructor throughout this course. I have 5 CCIs: CCI in route switch, security, collaboration, voice and service provider. So let's look at BGP attributes. Now, routers running BGP typically receive paths to destinations from multiple neighbors. So in that case, how would a router select which path should I choose? So for example, let's say if I was a router and I had 2 ISPs and both the ISPs are sending BGP routes to me, how would I select which ISP should I choose? Well, BGP does not have a specific metric. Like for example, OSPF. OSPF uses metric for path selection. EIGRP uses k-values, bandwidth and delay by default for path selection. BGP does not have a specific metric. BGP uses attributes to do a path selection. So based on the attributes, whichever is the best path, that goes in the routing table. Now if you had multiple paths, BGP will compare the first path with the second path. Whichever is the winner between the first and the second path, the winner would be put in the routing table. So it never puts both the paths in the routing table. BGP does not do load balancing by default. It never does load balancing by default. You can do load balancing if you want, but by default BGP does not do load balancing. So again, coming back, how does the router select ISP1 or ISP2? Like I said, it's based on attributes and there is no specific attribute. There are a list of attributes how BGP selects the best path. Let's have a quick look at that list, how BGP selects the best path. Well, BGP path selection is based on various attributes. These attributes are categorized as well-known versus optional. Well-known means all BGP implementations would understand those attributes if configured, and optional means you may understand or you may not. As far as well-known is concerned, there are again 2 subcategories. We have mandatory versus discretionary. Mandatory means it must be present in the BGP update, and discretionary means it may not be present, but if it is present, because it's well-known, you must understand it. So here, as soon as you receive a packet or an update from a BGP neighbor and you have multiple paths to a destination, BGP runs this algorithm, which is the path attribute selection algorithm. It runs that. The first one in the top of the list is wait. Now, technically before wait, there's one more, which is next hop. Because next hop is basically that if I receive a route from you and if the next hop is not reachable, I won't accept that route or I won't put that route in the routing table. So there's no question of path selection. So technically there is next hop before wait. But from changes perspective, if you want to make some changes, then obviously the first one is going to be wait. Now wait is Cisco proprietary, so it's not well known. It is optional. So other routers or other BGP implementations, other vendors may understand, may not understand. They don't need to understand. It's Cisco proprietary. Is it transitive or non-transitive? The meaning of transitive is that it can be sent across multiple ASs. But wait is locally significant to the router. It cannot be sent to anyone, intra-AS or inter-AS. It is local to the router. So wait is non-transitive. Higher wait is preferred. Default wait is 0. If you've learned the route through BGP, if you yourself have advertised that route, then the default wait would be 32768. Higher wait is preferred. If the wait is same, it goes to the next criteria, which is the local preference. Local preference is a well-known attribute, which means every BGP implementation would understand local preference. Is it mandatory? No, it's not mandatory. It is discretionary, which means that it is well known. Everybody will understand that. It doesn't need to be present in the update. But if it is configured, then every BGP implementation must understand the local preference. Again, higher local preference is preferred. The default local preference is 100. Is local preference transitive? No, it's not. It is kind of a partial transitive because it is transitive within the AS, but it's not transitive across ASs. The definition of transitive is that it goes across all ASs, but it does not. So I cannot send a local preference outbound to an eBGP neighbor. I can send a local preference outbound to an iBGP neighbor. It is transitive within the AS, but it's not transitive across ASs. So local preference is well known, discretionary, non-transitive. Higher is better. Now, if the local preference attribute is same, so if I have received routes from two neighbors and the local preference is same, weight is same, it goes to the next criteria, which is locally originated. So if I have learned the route through BGP or if I have locally advertised that route. Locally advertised could be through network statement or through redistribution. Doesn't really matter. If I have advertised that route would be preferred over a learned route. So locally originated is preferred over a learned route. If that is same, if I'm learning the route from both the ISPs, it's going to be the same. It goes to the next criteria, which is AS path. AS path is a well-known mandatory attribute. Well-known means that every BGP implementation would understand that. Mandatory means it must be present in the BGP update. It is completely transitive, which means that AS path is sent across all ASs, You can configure AS path outbound to an eBGP neighbor. You can configure AS path inbound from an eBGP neighbor. It doesn't really matter. It is completely transitive. Lower hops of AS is preferred. Now, if the AS path is also the same, if the hops of AS is also the same, it goes to the next criteria, which is origin. So, basically origin type. There are three different types of origin. One is IGP, one is EGP, and one is incomplete. If you have advertised the route through the network statement in BGP, the route would be tagged with the origin type as I, which is IGP. If you have advertised the route in BGP using a redistribute statement, then the route would be tagged with the origin type as incomplete, which is question mark. If you've learned the route through EGP, EGP is no more there. This was before BGP. So, in fact, all Cisco routers don't support EGP anymore. You'll only see two origin types, I, which is IGP, or incomplete, which is question mark. So, if you've learned the route, or if you've advertised the route through a network statement, it's going to be as IGP. Or if you've learned the route, or if you advertise the route through redistribute statement, it's going to be tagged as incomplete. IGP or I is better than incomplete. So if both the ISPs are sending me I, then it goes to the next criteria. Now if one ISP is sending me I, which is IGP, and the second ISP is sending me incomplete, then IGP or I would be preferred over incomplete. Now, if your origin type is the same, it goes to the next criteria, which is MED, multi-exit discriminator. Now, MED is not well known. It is optional. It is non-transitive. So, it does not need to be present in the update. You may understand or you may not understand because it's not well known and it's non-transitive. Lower MED is preferred. Default MED is 0. Now, if the MED is same, it goes to the next criteria, which is eBGP path is preferred over iBGP path. So, if my neighborship with ISP1 is an eBGP neighborship and my neighborship with ISP2 is an iBGP neighborship, then eBGP path would be preferred over iBGP path. Okay? Now, if that is same, what next? If that is same, it goes to the next criteria, which is basically going to be that the lowest IGP path to the BGP next hop. So, what's my cost? What's my IGP cost to the next hop ISP neighbor of this path, and what's my IGP path cost to the ISP2 BGP neighbor. Whichever is lower, that goes in the routing table. If the cost is same, it goes to the next criteria, which is going to be oldest neighbor. So it looks at which neighbor came first, who gave me the update first. But there's a slight possibility that maybe both of them sent you the update at the same time. So in that case, it goes to the last criteria, which is lowest router ID. So whichever neighbor has a lower router ID wins, and that path would go in the routing table. So this is how BGP does path selection. Remember, BGP does not do load balancing by default. It will skim through all of these attributes, top down, from weight to local preference to locally originated to AS path to origin to MED to eBGP path over iBGP path to IGP cost to the next hop, to oldest neighbor, to router ID. Again, router ID, lowest is better. And it selects the best path. It does not do load balancing by default. I hope this video was informative to you, and thank you for viewing.